T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0. And liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
Program is in right on time. 180 operating on % plus as expected. And throttling down to 76%.
Good afternoon, everyone. This is our post-launch news conference for Mars Science Laboratory and Curiosity, launched this morning on an Atlas V rocket. And here to talk about Curiosity and its state of health on the way to Mars and the agency's reaction to this launch is Pete Teisinger, the Mars Science Laboratory project manager from the Jet Propulsion Laboratory, John Grotzinger, the MSL project scientist from the California Institute of Technology, and Doug McQuestion, the director of the Mars Exploration Program at NASA headquarters. And we'll start first with the MSL project manager, Pete Teisinger. Pete.
Good afternoon. Our spacecraft is in excellent health, and it's on its way to Mars. Okay? And questions? I'm sorry. I'll talk about the spacecraft health in a second, but I want to give a tremendous thanks to the launch team, ULA, and to the launch service provider organization here at Kennedy, and to Kennedy Space Center, who's been have hosted us since we arrived in May and June, and built up the spacecraft and did final testing here and finally encapsulated for flight. They did a tremendous job today. They've done a tremendous job for all these months, and it was a fantastic and smooth operation today, really just first-rate and tremendously professional. As I said, the spacecraft is in excellent health. You may have seen pictures of the separation, weren't those fantastic photographs? And we separated perfectly on time, of course, and the acquisition of signal was as expected about 6 minutes later, 15:52:27, if you want to know, Zulu. The power, we are power positive, slowly charging the batteries. We did not lose that much state of charge, in fact, during the ascent profile. We're thermally as expected. The cat bed heaters for propulsion are on. The temperatures are as we expect them on the key pieces of equipment, and we're changing slowly, as you'd expect, as we transition from ground-based to space operations. We are in cruise mode. We have commanded the spacecraft, and we are therefore in two-way and are getting navigation data. The injection was first-rate, much less than 1/10 of a sigma is both ULA and our navigation estimate. So it was a fantastic, accurate injection. And that's about it for me. Very happy guy.
Thank you, Pete. And now John Grotzinger, the project scientist from the California Institute of Technology. John.
Well, I'm also really excited, I think, on behalf of every scientist on this mission, and there are about 250 of us. I would like to thank every engineer at JPL, everybody that has worked so hard for almost 10 years to build this spacecraft, put it together, all the principal investigators who have dedicated their lives to building the instruments for just as much time, and all their team members that have helped with getting surface operations. We are ready to go for landing on the surface of Mars, and we couldn't be happier. I think this mission will be a great one. It is an important next step in NASA's overall goal to address the issue of life in the universe. We are not a life detection mission. We have no ability to detect life present on the surface of Mars, and it is important to distinguish that as an intermediate mission between MER, which was the search for water, and future missions, which may undertake life detection. Our mission is about looking for ancient habitable environments and a time in the history of Mars that is very different from the conditions that you see today on the surface of Mars. We have a lot of evidence that has brought us to a single landing site. the result of 6 years of deliberation over more than 50 potential landing sites. The engineering system on this mission that will land us on the surface of Mars for the first time in the history of any landed mission to Mars gets the scientists to exactly where they wanted to go. There's no compromise. We are going to the very best place that we could find to go to, and I just can't wait to get on the ground.
Thanks, John. Now, Doug McQuestion, the Director for NASA's Mars Exploration Program at NASA headquarters. Doug.
Ecstatic is the word. I mean, the agency has been working this mission hard with JPL and all the other organizations such as Department of Energy, our international partners, and now KSC and ULA have put us right where we wanted to be. Moving fast, cruising to Mars, hot, straight, and normal, right? In good shape. So the agency is ecstatic. I mean, we have started a new era of exploration at Mars with this mission, not just technologically, but scientifically, as John said. I hope we have more work than the scientists can actually handle. Once we get to the surface, I expect them all to be overrun with data that they've never seen before. I expect the public to have images, vistas that we've never seen before either. Down in the bottom of Gale Crater when we land, those first images are going to just be stunning, I believe. It'll be like sitting at the bottom of the Grand Canyon, I think. So we are absolutely ecstatic. Can't wait to get to Mars. Also need to thank the JPL team. Pete, you and your guys, John, for getting us to this point. It's an enormous mission. It's equivalent of 3 missions, frankly, and quite an undertaking. Science fiction is now science fact. We're flying to Mars. We get it on the ground and see what we find.
Thank you, Doug. We're ready now to take questions. Please give your name and your affiliation when the microphone comes to you. Let's start here in the front with Marcia.
Marcia Dunn, Associated Press, probably for Mr. Theisinger. But, you know, we've heard that the Bermuda Triangle awaits you. How, is that even on your mind today? I mean, are you quickly putting the launch behind as a success and now looking forward to this 8-month cruise, or?
What launch?
What launch? Yeah, exactly.
Well, you can't, you know, we clearly been thinking about intercent landing for quite a while, as well as thinking about the surface mission for a while. But you gotta, you know, today's today, and we need to let everybody enjoy the moment. We all recognize this is the prologue for the mission, necessary but not sufficient, and we all have our work cut out for us in the next 8.5 months to prepare for a surface mission and do the final I-totting and T-crossing for EDL. But today's a great day.
Right here.
Jim Siegel, Celebration Independent Newspaper. I believe this one might be for Doug. I noticed in some of the press materials that we received, there have been maybe 20 or 30 different missions that have been sent to Mars, or at least attempted, since 1960. And there are several that are planned, or perhaps not budgeted, but at least planned. And I wondered if you could tell us a little bit about what's the next step is after Curiosity and the Mars Science Laboratory.
Sure. The next mission is an orbiter, the MAVEN mission. So we'll be back in 26 months. So we told the ULA guys and the Kennedy Space Center folks this morning to be prepared. We are coming back. So MAVEN mission is an exciting mission. It is an orbiter, as I mentioned, but it's also an atmospheric escape rate mission. So one of the keys to what's happened to Mars and moving it from I'm talking about your category now here, poke me when I say it wrong, moving from a wet planet, a warm and wet planet in the past, to a cold, dry planet that we know now with water that's significantly under the surface but at the poles, is what happened to the atmosphere. And MAVEN's mission is called Aeronomy, and the job is to try to help understand what the escape rates of the atmosphere are now, the interaction with the solar wind, and if we can try to understand the history of the atmosphere that actually helped change the planet. So it's a planetary evolution, in a way, mission. That's the next exciting mission. That's a 2013 launch. And after that, we're still in discussions with the Europeans. We're looking at, as you said, there's a number of different missions that we're planning, potentially trace gas missions, which is what we'd like to do. Hopefully another lander in 2018 that will continue moving the science forward, that MSL will start in that new era of seeking the signs of life.
Just a quick follow-up. How many additional missions would you envision then between now and when we might actually try manned exploration of the planet?
There's a series of precursor measurements that need to be done, better understanding of the dust and of the regolith and how it interacts with hardware and equipment, toxicity of the soils, how easy it is to extract water and things from the materials that we have on the surface, and maybe other materials that could be useful. That's a series of precursor missions that we actually don't have on the books quite yet. We've had years of discussion about what those might be and how to go about those things. But there's a balance of scientific missions and human exploration precursor missions that have yet to be discerned what that balance is going to be. The big issue with getting humans to Mars, frankly, is entry, descent, and landing. Pete and the team, the Mars Exploration Program, are about to put the largest vehicle on the surface ever put down, a metric ton, well, 900 kilograms to be exact. When you're talking about humans to Mars, you're talking an order of magnitude almost more than that. You're talking, well, a couple of orders of magnitude in some cases. You're talking 40, 50, 60 kilotons and metric tons, excuse me. We don't know how to do that yet. We actually don't know how to do that yet. That's more of the technology tall pole than the scientific precursor missions are.
Thank you.
Irene?
Thanks. Irene Klotz with Reuters. In one of the earlier briefings this week, I guess it's still, Mike Malin was talking about the huge amounts of data that will need to be coming back just from the images. And I was wondering if any of you could just talk a little bit about what your plan is for managing the communications and if there's a backup in case MRO, something happens with it and that's not available.
You want to talk, Colin?
They seem both to be looking at me, don't they? Well, we have a UHF relay communications planned through both Odyssey and MRO, and we do have a very, very limited X-band communication with the ground. So I think that we will prioritize the data and send it down in the priorities that both the engineers and the scientists want to have. It is likely that with the cameras being able to take so many pictures that we are going to have data that we're not going to be able to ever return. I think that we will have to prioritize and send it back, and that's just the fact that our telemetry link is not as good as our data acquisition process on the planet. I think that we firmly expect MRO. There's no reason not to believe that MRO will be there for the entire mission and do an extended mission. I think Odyssey is a little bit more of a question mark, although the latest data I've had on its gas utilization indicate that it is still quite an expected life. So that's where we are.
If I can inject on that also, Maven is carrying Electra radios also. So Electra radios are a software reprogrammable radio that it does the primary uplink, downlink from the surface. And so as we go through orbiters, that's why this program is set up as a program, and it's not just individual random missions. That's one of the reasons. So we will refresh that telecom capability of Odyssey and MRO when Maven flies, because it'll take an Electra radio to the planet as well.
I also had a science question maybe for you, John. I was just kind of curious if this suite of instruments that are on Curiosity was on the Viking landers, do you think that the results would be any different? Or do you think that the place where the Vikings landers touched down is just completely kind of antithesis to any search for organics?
Yeah. I think if you had the Viking Lander 1 and Viking Lander 2 sites on the list today, they wouldn't have made it past the first landing site workshop. And you sort of in those days you get what you can get to and hope to make the most out of it. The big difference we've got now is with the rover's capability is that we are A, mobile, and B, with all the instrumentation and all the people working on the mission, we have a much better chance to focus in on areas that we think are promising for the goals of investigating past habitability.
Okay, Craig?
Thanks. Craig Cavalt with Aerospace America. Kind of a lessons learned to this point question on development. I think you'd agree that the development of MSL was perhaps a bigger task than NASA believed it would be at the start. If you had it to do over again, what would you do differently?
You want me to take that one?
Yes, I do.
I thought you would. You know, NASA's here to do the hard stuff. If we were doing the easy stuff, we wouldn't be NASA, I don't believe. Have we learned lessons? Yeah, we sure have. We've learned lessons about how to manage certain things. We've learned lessons technically, what works, what doesn't work. We've learned lessons about lead times. We really needed those 2 years that we took. And it was important that we did that. And it was money that we're going to see real shortly is well invested. But you know, whenever you're pushing the envelope, scientifically or technically, it's going to be harder than you think it is. So I think the length of time we have for development is one of the key lessons that we've learned. And our intent as we go forward is to make sure that we aren't compressing the different phases of design and development when we're actually trying to do something new and challenging.
Yes, right back here.
Hi, Robert Perlman with CollectSpace.com. Sort of working off of Irene's question earlier about communication management, how will Curiosity's arrival on the planet affect Opportunity's mission? Will priority be given to Curiosity in terms of communicating with Earth?
I don't necessarily think that's an issue. We have the two orbiters. We are able to track both orbiters at once with multiple aperture per multiple spacecraft reactor capability for DSN. So right now I don't see a tremendous conflict in terms of our data needs and Opportunity's data needs as we go forward. Certainly hope that Opportunity is there, so we have that opportunity to share the link with them.
Okay, hi, Mike Wall from Space.com. So you guys are going to be gathering a ton of data, and there's going to be a real bottleneck in terms of sending it home. Can you just kind of talk about what that's going to mean for folks who are not necessarily scientists but are interested in what you guys are discovering, like the views and the videos? How fast are you going to be able to get that stuff down? And I mean, how much are we kind of going to be able to see of these vistas that Curiosity is seeing?
I think John may correct me, but I think our current data rate is around, is it 250 megabytes per day that we should get down. So that allows quite a rich amount of data. I don't, you know, in my caution before, I certainly didn't want to indicate that we were going to get 1/10 or 1/100th of the pictures down. I don't think that's the case. But certainly we're not going to get 100% of the pictures down. And we will pick and choose because the scientists will want very much to get the right context pictures to do the rest of the science investigation that they need to do.
Let me just add to that a little bit. The principal investigator, Mike Malin, when he designed the cameras, each camera has its own buffer, which is 8 gigs. And the science plan this time around is going to be a little bit different than what happened with MER. On MER, the science team would look at the NavCam images and then based on those, select some subset of images to then shoot with the PanCam. This time around, what the PI would like to do is shoot a broader vista right away and return thumbnails. All thumbnails will come back. Then the science team will actually look at those color thumbnails and from that be able to select what subset you would actually downlink. So the buffers exist as a data management process to allow much bigger data sets to be acquired with the full intention that some subset of it will never be returned probably.
Scott Powers from the Orlando Sentinel. Pete, are there any upcoming significant milestones or challenges between now and August for this flight, or is it just going to be an ice cruise for 8.5 months?
Yes, we've got an engineering checkout that will occur in a few weeks and a science instrument checkout that will occur sometime thereafter. We have, of course, 6 trajectory correction maneuvers to engage in. The first one will be about 15 days out from today. The second one approximately 2 months out, and the third one about a month or so before we get to Mars, and the last 3 are for fine-tuning the entry, descent, and landing corridor. We are also planning 2 software loads, one in May to be the final update of the software for EDL and in the last phase of the mission, and one in June for a surface mission. So those are the key kind of major events that will be engaged on the spacecraft. On the ground, we'll be engaging in operational readiness tests, and we have about 10 planned between now and August. So we're going to be clipping off at more than 1 a month, 3 of them for entry, descent, and landing, and 7 of them for the surface operations.
To clarify, you said there are 3 trajectory between now and when it reaches Mars?
Right. There's a major aim bias that takes place when you go to Mars because the second stage, the Centaur's also going to Mars. And it's not treated from a planetary protection standpoint the same way the spacecraft is treated. So the aim point right now is quite a bit away from Mars. And so the first trajectory correction maneuver will be to correct the aim point for what we want the entry point to be. All the trajectory correction maneuvers after that are basically to take out the errors of that first trajectory correction maneuver.
Okay, Ken?
Hi, Ken Kramer for Spaceflight Magazine. Question for John. You said the other day and today also this is not a life detection mission. I wonder if you could describe a little bit what kind of instruments you'd like to have to make it a life detection mission in the future. And a question for Pete. When you do get to Mars, you're going to be monitoring the weather so you can make last-minute changes in the entry, descent, and landing profile at all? And other atmospheric data, too. Thanks.
You're up first.
All right. So what I would want is lots and lots and lots and lots and lots and lots of rovers, because what we learn on Earth is that you need lots of humans to go out in the field and rocks that are 3.5 billion years old to actually find something that you can look at and hold up and hold a press conference like this and say, I found evidence of life on the early Earth. And again, I'll emphasize this throughout the mission. The great paradox here is that water, the very thing that enables life, when you convert loose sediment that might have microorganisms in it, and you convert that to solid rock, that requires circulation of many, many pore volumes of water, and water is an oxidant. So the water actually oxidizes the organics. And on Earth, the exploration for fossils that might be present in ancient rocks is quite serendipitous. You have to sort of learn how to get to a good spot that looks promising in terms of kind of cementing the material in very early on. If it happens later on, that's no good. You want to get it early on because most microorganisms degrade within hours or days. So you got to get them locked in early. And with that paradigm, then you begin to just poke around, and it's just really just collecting many different kinds of rocks. So I would imagine that what we could do as far as exploring ancient Mars is concerned is you do need to explore probably a couple of different of these landing sites and learn to become familiar with the patterns by which water converted materials, including potential organics, into rocks. So, and then in addition to that, you would need very specialized microscopes that you could use to take rocks on Earth. We cut them so thin you can pass light through them. And then you can see actually cellular structure and distinguish that from abiotic processes. The other option is to find what you think really is sort of the glory hole and get a piece of it and return it back to Earth. So, I think that latter option is the direction that the Mars program is headed in.
Okay.
The current instruments on MRO and Odyssey and Mars Express will in fact look at the atmosphere and give us data on any changes in the atmosphere that we might see. We don't expect this to have a dust storm because this is not dust storm season, but there could be inflation in the atmosphere as a result of other processes. Our entry, descent, and landing simulations and testing has taken a look at extremely broad atmospheric distributions in terms of pressure and density profiles. So I don't expect any surprises there, but we will, of course, fine-tune the entry, descent, and landing timeline based upon what we see.
Gene McCulka with Talking Space. Question for John. We got a good idea of what the engineering side is doing on the cruise out. What is the science side going to be doing on the cruise out?
Right. So Pete mentioned operational readiness tests, and we have several of those planned for the science team. And what we do is we work with Curiosity's twin, which is back at JPL on the test bed there. And it has a high degree of fidelity compared to what the spacecraft is. It's on its way to Mars. And with that, then, we undergo tests where the team actually thinks about what kind of sequences they would like to acquire on the surface of Mars, as it were. They get implemented, they get built, they get radiated to Mars, the data gets returned back to Earth. And in this simulation, then the science team gets to practice with, for example, how you would do triage between the amount of data that's available, the amount of power that's available, the amount of time that's available. Basically, the three fundamental resources that allow us to do the science experiments. And so then, we hope then with the 10 instruments to be able to learn how to efficiently do trade-offs and work with the flight software and interact with the engineers that will be required to help us do everything, and lots of training there. Yeah.
I'm Roland Keller of Swiss Engineering. After this beautiful flight, I would like to know what do you think about the international cooperation after the program ExoMars.
I think I have to answer that one. We've been working with the European Space Agency for several years now, and we are continuing to do that. We met last night to continue discussions. It's a very important partnership for us, NASA, with both the 16 mission and the 2018 mission. We continue to pursue those, and my 2012 budget that was just passed by Congress recently supports that activity, and we will continue pressing that. As you know, we have excellent international participation on MSL. I hope I get them all. Canada, Russia, France, Germany are all aboard. And Spain, thank you. And Spain are all aboard. I knew I'd miss one. It's been a long day. And so, we work with the international community all the time. And this is expanding that with ExoMars, and we intend to continue to pursue that. So we want that to happen.
Todd?
Todd Halverson of Florida Today. I was wondering if you could tell us what you anticipate to get out of the descent camera, what we will actually see as a product of that instrument, and when we might see it.
So the descent camera turns on just moments before separation of the heat shield, and it acquires all the way to the surface at about 5 frames per second, full color HD resolution. And then after we touch down, it shuts off nominally. That camera is available to use throughout the mission on a best efforts basis after that. So that data set will be a very large one, and given the fact that we will want other critical engineering data to come down and also some other initial science products to come down, our guess is that probably initially within a week or two, there will be a subset of the frames that will be a pretty nice looking movie that will be available, and probably within a few months it will be required to downlink all of the frames that would give you the complete sequence, something like that.
Any further questions? Yes, we have one over here.
Thank you. Jackie Goddard for the Sunday Telegraph of London. Already our launch coverage online is generating the usual array of reader comments that question the amount of spending on a mission like this, and why aren't we feeding the world starving and frivolous and waste of money. Do you find that kind of attitude demoralizing, and how do you redress that lack of understanding of the importance of this science that you're doing?
Yeah, I think any one of us could take that, but Pete and I have often discussed this, especially in the context of the 2-year slip. You ask in retrospect, what does it mean that we've done that? I think you look back, and at least for this country, you take every child, woman, and man, and you divide the total price tag by the number of people, and it comes out to about the cost of a movie. So, I'll leave you to judge for yourself whether or not that's a movie you'd like to see. I know that's one I would. I think the cost is a bargain for education for all the science team members that represent other countries as well. This is the stuff that fuels kids' imaginations to go into science and engineering. I can't think of anything better. I have a lot of friends of mine whose kids were watching early this morning at JPL, and it's about as good as it gets, and I think that's a great investment.
I'd like to add the standard cliche to that, however, which is we don't spend any money on Mars, right? We spend it all here. These are high-tech, good-paying jobs across the country that are created when you do something like this. I've not actually counted it up, and I know that there are thousands of individuals across the country, anywhere from high school educations to PhDs, that are gainfully employed, exciting other people, as you said, to bring more kids into the engineering and sciences. And frankly, that's what moves society forward. Very important.
All right, if there are no other questions, we're going to conclude, but as we go out, we're going to show some video of the spacecraft separation today, which everyone agrees was quite mind-blowing. So we're going to go ahead and we'll show that, and then that will conclude this briefing. Thank you very much.
Five seconds, spacecraft set. Achieved our targeted roll rate. We have spacecraft separation. And confirmation from our video system. And the vehicle has despun.